Hi, in this video we will see how to create a schematic. Let us take an example of a very simple gate inverter. So in the previous video we had seen how to create the library and then a cell. I have already created the cell, and then we have also created the view schematic. So I have opened my schematic here. So the first thing I have to do is to instantiate my PMOS and NMOS. So you know that, right? In NOT gate, the transistor level diagram of a NOT gate or an inverter is we have a PMOS at the top and then an NMOS at the bottom, and then we have all the wires and the terminals connected. Now we'll see how to do it. So first instantiate. So browse through the library. First you have to go to CDS FFmpeg. Um, so you can just CDS type CDS and then you will get it here. So here I have, and then you have already P1 SVT here. You can just browse it everything, and here the name is optional. You can give some specific name like PMOS 1, PFET 1. So this is 18 nanometer technology, right? So you can give it as PMOS 1, PFET 1, anything like that. And then here only you can give the number of fins, how many it should have. I'll keep it 3 fins, and then this is the minimum channel length that I can have. Below this I can't have. Even if I change it to, you can see, 10 nanometer. So by default it is 18 nano. I can keep it more than this but not less than that. Okay, I can even not change it to 22 nanometer. Okay, so yeah, it is fine. Then this is about the number of fingers. I will keep it to one. If you are doing a multi-fingered transistor, then you can increase the number of fingers to the required number here, and then it will start showing layout parameters. So since we are doing schematic, we need not worry about this actually. So we can keep it them to the default as of now, and I'll click on hide. So I'll click keep it my PMOS here, and then uh, I have to instantiate my NFET. In fact, this is PFET, and that I have instantiated. Now I will be instantiating my NFET. So now I have to browse through. My NFET is N1 SVT. So the naming convention is just N stands for NFET, and SVT stands for standard VT. So you will be having multi VT library. This is a multi-VT library. You have SVT, standard VT, LVT. You can see here LVT, and then you have HVT, high VT. H stands for high, L stands for low, S stands for standard. So similarly, you have the same three different types in PFET as well. Okay, then again, you have to select the symbol view while instantiating in the schematic. So I have that symbol selected. I'll keep it the name default. I need not. I don't want to give any name as of now. So here you can see this NM0 is the name that it has assigned the name default. And once to instantiate, I is the shortcut that you have to do. If you press I, it will start opening the form, the add instance form. Then you can instantiate. And to come out of the instance mode, press escape. So yeah, now to fit to the window, I have pressed F. Now you can see all the things are fit properly. So if you have something like this or zoomed extremely like into it, then you can simply press F. F is for fit to window. Now, now you click on W, because we have to join these things using wires, right? So to enter into wire mode, you click on W. So just observe the pointer there. So now it has entered into wire mode, and if I have to go out of the wire mode, I will be pressing escape on my keyboard. So now I have to join these things, right? So I will enter into the wire mode first. So I will join the drain and drain of the PFET and NFET, and then I will join the input side, that is gate terminal of PFET and NFET, and then I will be connecting the source to the VDD for PFET, and I can just connect this one like this because body terminal of the PFET is connected to the VDD, right? So again, I can keep it like this, and to draw a wire, you start where you want to start, and then where you want to end, you will be just clicking on it. Say for example, you want to start a wire from here, you click on at this point and it will start. Click and release. Okay, just click and release, then freely moving. My mouse is now freely moving. Now wherever I want to end, say I want to end it here, I will click here and press enter. So for example, I want to have the wire drawn like this and bend it here only. Say I don't have the control over the bend as of now. So I want to bend it here. So I will press it here. Now bend my wire in the required direction. Okay. So bend like this and click here, then again click here. So again I'm clicking here, so you can see wherever I'm clicking I'm getting a bend. So I want to stop it here. I will first click it and then press enter. So I'm stopping it over there. So this is how you create wires. Now to delete that, I will just select and draw a selection box and select all the unwanted wires and click delete, and then press fit to window. So for making the circuit look beautifully, I'm just trying to keep these things as symmetrical as possible. So you can also do the same. So and now I will be having I have to create pins, right? So before that, I will just extend these wires so that it can be connected to uh, input and output pins. This is for input pin and this is for output pin. This is for VDD and VSS. Now to create pin, again the shortcut key, or in general in Cadence it is called bind key. Okay, so bind key for the creation of pin is P. Once you click on P, the name you have to give as we will be creating our input pin, right? So I will give it as V in. Okay, and the direction is input. Okay, now rest all things you can keep it default and then click on hide. So input pin I have connected, and then again click on P. Then you have to create pin for V out, that is the output pin, and then click the direction as output and it will start it appearing here. Then click on hide and then uh, connect it here. Then now I have to create pins for VDD and VSS. So what I will do is both are of the same direction. I will keep it input output for VDD and VSS, and here VDD space VSS. I need not, I created input pin one time and output pin another time, right? Because they are of different direction. Now VDD and VSS both are input output type. All those pins which are of same type can be created at a time like this. You just have to provide space between their names like this and click on hide. Now you can uh, keep the pin here and then VSS pin here, and then you have to come out of the pin mode, press F again. So now it is fitted properly to your window. Now what you have to do is you have to do check and save. So Shift X is the shortcut button for check and save, and if you are doing it through mouse you can also do it here. Also you have plenty of options here, and if you don't know what they actually do, you can just hover your mouse on it and see what they are there for, what their purpose is for. Okay, so here it is showing as check and save. Okay, so what it will do, check and save is for example, if you have made some kind of mistakes like not connected wires, unconnected wires are there, and if the pin name is not proper, or if pin is not connected to a Y terminal, then you will get warning or errors when you do that. If your circuit is not it won't give the verification about functionality, but if you have some unconnected wires and unconnected pins, then you will get that error. So I just wanted to show you how, like, what is exactly it does when you have such kind of things. So I will delete this wire, and then also I will create a small unconnected wire like this here, and then now I will come out of the wire mode and do Shift X. So now it started showing three warnings. So there are check warnings in training videos, inverter 1x schematic. So this is your training videos is your library, inverter 1x is your cell, and schematic is the view. So you have three warnings there, three check warnings there. It is saying close to how to know more information. Which are those warnings? How to get to know about further about these warnings? Go to CIW window. So here you have all the warnings listed. You can see. Okay, so you have this Wien floating output. It is actually an input pin. Uh, it For a reason it shows a floating output. Okay, so you need not worry about that. So that actually means this pin is just unconnected. It has not been connected to anything anywhere. So what you have to do is you just have to draw the wire and connect it. Then you have floating net. Okay, so now it is showing the coordinates of those of the pin. So these two are the coordinates you can see. So these two are the warnings, corresponding warnings. So what I have to do is I will just delete the unconnected wire like this, and then draw a wire from here to here. I will just connect it, and then press check and save, and then press F. This floppy disk icon is only save. Okay, it won't check any error. Okay, so this will check the errors and warnings. If it is there, it will give you the notification about it. Otherwise, it will just save the circuit. You have this circuit ready, and then finally every time you make some changes in your schematic, you need to do check and save. So please remember this point, and every time I am repeating, every time you made any minute change on in your schematic, to update that change and save it, you need to do check and save. So you will be doing check and save a lot of times, so please remember this point. So yeah, now we have our schematic for the inverter ready, and that's all about for this video. Thank you.